We're going to look at these three problems, and we are going to look at increasing, decreasing, and constant intervals. And these answers will be in interval form, which we have used before in trimester A. This page will go on, I do believe, page 19, but you might want to wait to put it on that page until Monday so that I can show you how to fold it. The biggest thing you need to understand about interval form for increasing, decreasing, and constant is that you will always use input values. And therefore that means you're going to be using the x values. Okay. So let's start with taking a look at one that's pretty straightforward. So we're going to look at the one in the middle. I'm going to use a highlighter to represent so that you can see what we're looking for. Input values are the x's. So what we're looking at is, where is the graph increasing? And you read a graph from left to right, just like you read a book. So since the slope is positive, the graph is increasing to right here. So this is increasing. The graph is going up. It's just like the distance, getting further away. And then what happens right here is the graph is constant. It doesn't change. It's where you're staying still. So from here to here, the graph is constant. And then the graph has a negative slope, so it's decreasing. And then finally, to finish it up, it's constant again and keeps going. Constant. So we have two constant sections, an increasing and a decreasing. The hardest part about this is understanding that you're going to be using the x values. So for increasing, it starts out here, way out here, to the left, and it keeps going to the left. But it stops at this value right here, and that value is 0. So it stops at 0, and we're going to use parentheses for this. So all of these will be parentheses. But the way that we represent that this is from the left forever, as it comes out, left forever, would be negative infinity. And that's something difficult to understand because it looks like it's going down. But it's because it's coming in from the left. Then what happens is it's constant. From this point to this point, it's constant. So that starts at 0, where this one left off, and ends at the input value of 3. Then the graph decreases starting at 3, and it decreases to right here, which is the value 6. Then at 6 it picks up and it's going to be constant again, so we put a U to show that it's going to do it again. Starting at 6, it's constant again, and it's constant forever. And forever in math is infinity. So since this graph has an arrow on the left side and an arrow on the right side, we have to have a negative infinity and a positive infinity. So again, the graph increases from the left up to the x value of 0. It's constant from 0 to 3. It's decreasing to 6. And then it's constant again from 6 on. And again, it's all about the input values, or the x values. Let's take a look at this second picture on this side. Again, we're going to read a graph from left to right. So, since this is negative slopes, this is decreasing to right here. So we're going to use D for decreasing. Then it increases because we have a positive slope. Then it decreases because we have another negative slope. And then it increases. So in this case, we have no constant sections. So the graph decreases from the left into this value, which is -3. It increases from -3 to this value, which is 0. It decreases from 0 to 3. And then it picks back up from 3 all the way, arrow, to the right forever. The hardest part is understanding this is actually coming in from the left as it comes down. So left forever, and it's decreasing, is -infinity, and that stops at that x value of -3. Then it increases starting at -3 to the x value right here, which is 0. It's going to decrease again, so we're going to put a U to show again, and it starts decreasing at 0, stops decreasing at 3. Then it's going to increase again from 3 to forever to the right, so we put U. 3 to forever to the right is infinity. So one more time. The graph starts on the left side and it's decreasing because it's coming down. We read it from left to right. So it's decreasing to -3. At -3, it's got a positive slope, so it's increasing to 0. At 0, it starts decreasing with that negative slope again to 3. And then at 3, it increases, and it increases to the right forever. So negative infinity is left forever. Left forever is -infinity to -3. Increases from -3 to 0. Those are those input values. Decreases from 0 to 3. And then picks back up from 3 to the right forever, which is infinity. There are no constant sections because there's no part of the graph where it's a straight horizontal line like it is in the first picture. Our last picture is this upside down U shape. This shape is a parabola, which we'll be studying quite a bit. So again, you read a graph from left to right. So if we read this, this is on the left side. It's not a necessarily slope, but it is coming up to right here. So it's increasing. And at this point, which is actually called the vertex, it's going to start, change its direction, it's going to start coming down. So it's decreasing, and it's decreasing forever on the right side. So left side forever is -infinity, right side forever is infinity. Even though that arrow is going down, remember we use inputs. Those are x's. So increasing is where this starts because we read it from left to right. So we follow it up, then we follow it down. And the place where it changes is 0. So it's increasing from -infinity to 0, and it's decreasing from 0 to infinity. And there are no constants again on this one. So one more time. It's going to graph, we're going to follow it, read it from left to right. This is left, so we're increasing, call that I. And and then we're decreasing, and that's the right side forever. So left forever is negative infinity, right forever is positive infinity. So it's increasing from negative infinity to 0, where it splits apart there, and then it's decreasing from 0 to infinity. Now we will talk about these other things that are on this paper on Monday. There is a homework assignment that you'll get with this. It's a stapled paper, and the ones that have the dots next to them are the ones I'd like for you to try. Also, there are some that you have to graph that are piecewise functions. You've been graphing piecewise functions already. So the second two in that packet have the piecewise functions that we've covered, such as y f of x equals, and it's got 2 pieces, I do believe. So you should graph those first and then try to answer those questions that I put a dot next to. There's one more video attached to this, and that's to explain the Sudoku puzzle, and the due date on that is Tuesday, but that'll be the last video.